Oh man, it's dark outside meanwhile, and I copy and paste numbers from Excel to Matlab for hours now. So it's not the thing what I want to do the whole day. So therefore, we have to find another solution. We need to learn Matlab and real Matlab programming so that we can read data and that we can process data line by line or also until a special condition happens. Okay, next step, Matlab in a programming environment. So, welcome again to the next lesson for programming Matlab. Last time we learned about the interactive use of Matlab. So, what we did is that we entered commands directly into the command window and we did some selections in matrices. We did some plotting, so it was quite helpful. To prepare data, to get data, to select data, to manipulate data, all of this stuff. But we did it manually, so we always entered the commands directly and we checked the results. Today we want to go the next step so that you prepare a sequence of commands and that these commands are started by a user or a, let's say, customer of your program, and then it flows through these commands, makes some decisions if special cases happen, and then you see the results. So we go the step towards to a use of Matlab as a real programming language, not just as an interactive language. And therefore, we will have a look into the following points. First of all, I will explain the concept of programming. So about the concept of M files, which can be scripts or functions. And then we will discuss the application flow, so that we have a workflow which runs through a special set of program commands. And then we'll have a closer look into input and output and about efficiency, and you can also make some animations with this stuff. So let's directly continue with the first things. Before you start with programming, again, the hint, if you have some questions, search the internet or also use some very helpful tutorials like this Matlab primer, which is referenced here. And also, if you have already special needs and you already know about the function names and things like that, you will find a lot of help pages on the MathWorks webpage. You also have some blogs where you find things about Matlab. And of course, Matlab directly offers the help command or the help button, so search also these things. It's just a reminder that you can do these things. What we want to do today is that we create own functions with special purposes so that we can extend the existing Matlab language with our own functionality. So we'll leave, as I said, the interactive mode towards a more programmable mode where we extend functionalities. We operate with variables which we already created so that We already used the knowledge from the previous lesson, and we will extend it with special conditional statements, with repeating statements, so that we have loops. We'll do input output by the user or by program files and so on, so that we have a new setup which is more or less extended, and therefore we have also to prepare a special structure of our code. So let's start with the programming script files. In principle, what you can do is that you use a sequence of already entered commands. So there is a nice tool which you can use for that. It's not exactly what you need then for the program, but it's a record of entered commands, so that you can copy and paste things what you already have done. The command is diary with a file name, and then from this point on, everything what is plotted or printed by Matlab is recorded. So it's a file, a text file. Everything, each entered command, each printed output will be then in this file until you write diary off, and then you have something like a sequence of program code, but also with extension of the output. So therefore, if you use this with a semicolon, then you might get a program, but it's just a helping utility, so it's not really programming. If you do a really program style, then you will write own files with an editor. So you will use an external editor. Matlab also directly offers an editor, so I can show you this. Here on the top you find this editor. So it's a regular editor where you can open files, where you can create new files, where you can save files. You can do search and things like that, and you can also compare files. And a nice thing is you can directly run it. So if you push this button here, all of the program code parts will be operated here in this command window. So with this editor, you now write sequences of commands which are not directly operated or processed. So let's do this, that you understand the step towards to this programming stuff. So what you already know is that we entered here clear all, close all CLC, for example. So if we enter this, each command is directly processed. Now we go to this step of the editor. So we create clear all here, close all, and CLC, and you see it's not directly operated here, so it's just in a separate file, and this file must be started. So to start this file, I have to store it in a special file name. So I save it, and it's now in the file. This is my first program.m with the extension m. All extensions .m are automatically understood by Matlab as a programming file. And then I can operate this by pushing the button. And if I push the button, the whole stuff here, so all commands, will be operated step by step. So it will do the first line, the second line, and the third line, step by step. Let's push the button. So you saw that it was started, and it did the things which we programmed. So it's not so spectacular because we don't see that something changed. Therefore, we create a matrix which has the values and you will see that if I start this program now, that this matrix was created. So all of these commands are operated, and the matrix is now available in the workspace. So this is a regular Matlab script which you can program, and where you can make your own complete set of commands. You can also start this program if you enter the name of the file. So in my case, it's this is my first proc, and if I start this, it's also operated. Okay, so you saw the principle. We do not enter code anymore here in the command window. We now enter code directly here in an editor, and then we run the complete sequence of code in one step by clicking the push button or by calling the program with its name in the command window. So now we are already able to program. This means we can write our own programs. Everything what we have learned last week is now accessible as a program. So you can do the plot, you can do the creation of matrices, you can manipulate the matrices, things like that. What you not learned is the interaction to the user and the interaction to files. There is another thing which you have to learn according to programming, and it's this here, so the step 2. Because Matlab also supports to create functions, and we'll have a short look later on here, and we will then use this later on in the project. But first of all, let's continue. A short repeating. So what did we do? We created a text file. Then we started this text file so that all of the commands in this text file were processed at the time when we clicked the button. And what was created, you see it here. So we created global variables. So this means after we stop or after the program ends, everything what we created will be available in our workspace. So therefore you have to be careful what you create. For example, if you create counters in a for loop, what you will see later on, everything will be in the workspace. Also after the program stopped. And therefore you have to clean up your stuff. So you will have not only to use clear all, you will also have to use clear and then a special name which you created, for example, to delete a matrix or a vector. So take care in this, that everything what you create inside of such M file or M script will be in the memory after the script stopped. You store these files then, quite simple, in a special folder. You can change this by setting the path variables, but usually you have it in a special folder. In all modern programming languages, you will have it under your user. In some older languages, in some older operating systems, you will have it somewhere on your hard drive. So you store it there, and then Matlab always searches the search path. So it starts with the user file. So everything what you programmed into your folder will be then operated first. So if a file exists with the same name in this folder and in another folder, for example, of the Matlab system, then your program will be operated first. So you always have a search path through all of the program paths, and then the script file is loaded and you can run it. What you also should keep in mind is this here. So if a program runs and you have the situation that it will never stop, how can it be? For example, you create a loop which will never end. So you have a conditional loop where code will be operated all the time and the condition will never be reached, so that never ever the program will stop anymore. Then you have the only chance to stop the program by Control C. So if you want to interrupt the program and if you want to stop this, then you can push the Control key on your keyboard in combination with C key, and then the program will stop and there will be an error message in the command window. But this is quite important because I'm really sure that you will program in the first steps some loops which will never end. Okay, so let's continue. To do some work with Matlab, you need interaction with your customer or user, and therefore there are some commands which are quite helpful. You already saw the first command, so disp, we entered disp hello world. Do you remember? So it's display. You display something on the command window, for example text or the content of a matrix, and you don't need the version with this semicolon. So for example, if you enter a command without a semicolon, it will also print the result, but in this case you can have all of the things with semicolon, and you can use display to just display things which you really want to display. According to display, I directly jump to the third command. The third command is the opposite of display. You can enter something. So for example, you can request input from your user, so from the person sitting in front of your program, and we directly do this now. So what we do is we want to change this matrix which we created, and therefore we want to ask for a new number or value for a dedicated position. So therefore we can enter display. So we request something, so display, please enter value of position 2, 3. So that we request an activity by the user, and then we get this variable back if we call input, and then we can set the prompt. In my case, the prompt should be value question mark. So this value, this text will be printed instead of this prompt here, and the computer will wait for some input. And we have to store this input somewhere. So therefore, if we want to change 2, 3 in the matrix, we directly can change the matrix. So input is a function like all of the other functions which you have already seen. For example, flip left, right, or whatever. You saw that you have the name of the function, you have handover arguments. In this case, we have the prompt or the prompt text, and then it returns the entered thing to position in the memory. So, and if you start this now, you will see that the program starts, it clears all, it closes all, cleans up our workspace, and then a matrix is created, and then we print our question or our request, please enter value of position 2, 3, and then our new prompt appears and waits for input from the user. So in this case, input from me. So I now can enter a number, like let's say 32, and if we enter this, then 32 should be written to the matrix. So you see, it directly changed this. So I had an interaction with the user of my program, and therefore the user can change values and can also influence the behavior of my program. So if we jump back, I also can tell you that there is a way that all of the commands are printed automatically during the run of the program. This is sometimes helpful if you want to do some debugging. In standard mode, so in default mode, it's off. So this echo on and echo off is a helpful tool if you want to see what the program does at the moment, but it costs a lot of time. So everything what you print, everything what you interact with the command window will cost time. There's another command keyboard which is part of this input-output activity in real time, so that you can change control of workflow to keyboard so that variables can be manipulated directly while the script runs. It's sometimes helpful. But much more important is the timing. So if you want to interrupt your program for a special period of time, then you can use the pause commands. There are 3 here which you can use. So the first one just interrupts your program until somebody pushes a button on the keyboard. So this is the first pause without any argument. The next one is the pause with an argument. Here you enter the number of seconds you want to wait. For example, if you enter here 3, then the program will stop for 3 seconds. So this can help to have a better flow in your program in case of an interaction to your user. Or you can also wait for a button press, which means a mouse key press action. Okay, so that if you push the button on the mouse, then the program will continue. I can show you this in the Matlab directly. So that, for example, if we wait here for 2 seconds, then you will see that the program will interrupt. So, and if we start it again, you will see that it waits now for this 4 seconds, and then it will continue. So with this, you can have a better flow of your program as interaction with your user, so that it is not too fast in view of your user. Okay, so let's change. What you should know now is also that, as I explained, Matlab does not only offer the script files, which are sequences of commands. You have to separate now. So script files are usually control files. So they contain menus, they contain the main program you want to run. But the script files call usually functions. So as you know from the previous lessons, you already used these functions. So you used flip, left, right, up, down, zeros, pi, whatever. And now you can extend this with own functionality, so that you call your own function with your own name, and that this function does a specific, let's say, program part. The big difference is that you now have a real mathematical function. This means you have a name, you have input arguments, and you have return values. And these return values must be stored somewhere. And everything what happens inside of this function body, so you have this function header and you have this function body, everything what is inside of this is just inside. So if you create now a matrix inside of this function, it will not be available in the external memory in the workspace until you return it with the return values. So what you do is you use local memory. Do you remember? Scripts create global memory. Global memory means after the script stops, you will have this matrix available because it's in the workspace. You directly change this workspace. Local memory means you just create it as long as the function body is active, and then it's automatically cleaned up again. So it's quite helpful. And how is a function created? You will see it here if I turn me off. A function always starts in this file. So you have again a script file with a .m, but it now follows a special rule set. So it starts with the reserved word function. Then you name all of your return values. These return value names are the names which are used inside of the function. You can of course assign it to any external matrix or variable you want. So it's just the internal name of the values. Then you push the equal sign, and then you name your function. In this case it's called my factorial, and then you have in the parentheses the input arguments, a list of input arguments. And then you write what the function should do. This global result is just if you want the result automatically global, but you can also have it as a return value and then you assign it. So if you write this global result, then the result name is automatically available in the external world. In this case, if you don't do this, then it's really a return value. So I want to show you this directly in Matlab. So do you remember we had this, and I now change to a new editor, and here I created a new file. This is my first function, and then I have to follow this restriction. So let's say function, and it returns the internal sum equal, and then I have to name it. This is my function. So such a file can have several functions inside, but one of the functions must be callable from outside, so it must have the same name like the external one. So it's the same name like the file. So in this case I call it this is my first function, and I want to hand over a matrix, and then the function should do the sum. And to identify what is part of the function, it's always helpful if you enter some white spaces in front of the commands, so that you directly see everything what starts in a special column belongs to this part now, to this function, to this block now. So this is called indenting. So this indent is quite important also later on if you create for loops, and it helps you very tremendously to understand your code later on, because if you don't do this, it's an endless sequence of commands, and you won't find what belongs or which command is operated in a special block. So what we do, we call internal sum and assign the result of the sum of matrix. So in this case we now call this, we have to save it. We call this what we already know, so we create the sum, and this is a new function which we created. So we cannot directly run it because we need some handover arguments. So it's really now like a function, and we do not do the clear all, close all CLC here, because it's a small piece, a small module of new code which we call from another code. So for example from an, let's say, script file. So what we now have to do is we have to call this function like how we know it. So I do CLC, so that you don't see it. So we have to call this function like we know it from other functions. This is my first func, and then we hand over the matrix, for example, a matrix which we already know, and we can assign the result into a new variable, result. So if we call this, now matrix is handed over to this function which we created, and it is processed so that everything what is inside the code block of this function will be processed, and the return result will be assigned to the internal name, and this internal name is then assigned to this external name. So it's a real new function, and we extended the code of Matlab with our own code. And to show you what is the difference to the script, if I create here a new variable, for example test equal 1 2 3 as a vector, for example, then you will see that, take a look at this workspace here, so that vector, I'm sorry, I have to call it of course again like the function. So if I call this function here, this test is not available here. So the test is just available inside. To show you that it really exists inside, I can do the following. If I do some test, for example here, and if I assign it so that I calculate the sum of test and the sum of matrix, and then I sum both up so that I get the result of both sums, then you will see that the output changed now. So test really exists, but it just existed inside of this call, so only at this time when we really run the function. And this you should always keep in mind. So there is a big difference between a script and a function. The big difference again is that you create something like function bodies, and these function bodies use local memory. So everything what you create in this function body is not visible outside, so it's kept in this block. And therefore it's quite helpful because you do not waste your workspace outside. You don't have to take care of these cleanup things. It's really the concept of functions. So you have handover arguments and return values, and everything what you need outside, for example, by a script which calls your function, can be assigned again to the external world. And this is the real concept of programming. So here some other aspects of functions, so which you should directly get and know right now. But for the first steps, what we do in our project is that we will create scripts. So you should first of all learn the feeling of programming, and then we will convert everything to functions so that you really see the different concepts, also the different concepts in case of a larger project, so that you know what is in best case converted to a function, what is in best case converted to a script. But first of all, let's go back to the things of functions, so that I can continue with information about these functions, the basics of functions. So functions have this reserved word, they have return values, and they have input arguments, and they have an own optional to you defined name. They can have in this case more than one return value and more than one input value. They can have no return value, for example, so that you use it in this style. So they have different possibilities. Have a look into the help pages, for example. And functions, or one of the functions, must have the same name like the M file, so that you can call it. Functions will always be like this. You have this described header, so that you define the interface to your function. So it's called an interface because it defines things which you can give to your function, which you get back from your function. So it's like an interface to a small module block which processes then data. And then you have this function body. The function body is nothing more than a sequence of comments, again, which uses the internally defined variables or matrices, and also the defined names here in the input and output variables. So this is the general setup, and you should always comment your function things. So for example, also the steps in the function. But what is quite helpful are the first comment lines here. The first comment lines contain help text. Help text means that if you call help and then the name of your function, then this help text will be printed, and therefore you can say to your user what the function requests, what the function does, and what the function returns, so that with help directly you get the information. This is also this help text which appears if you start the function and open the first parenthesis, so that you have the first brace open, and then this small pop-up pops up with this information. A short hint here, you can have also optional numbers of arguments, so that you have, for example, a number of arguments which do not have to appear. The optional number is always counted from the upper right one. So for example, you can, if you have 10 arguments, you can have also 9, 8, 7 and so on, but you always have to skip the most right number of arguments. If you want to see this, then have a look at number of arguments in and number of arguments out. You can use it and can request how many arguments are used. As I said, we will come back to this function stuff again, because this is then the real programming for Matlab. A real Matlab programmer programs functions. So scripts are just, let's say, control sequences of programs, but a real programmer in Matlab really uses this concept of functions. We'll come back to this later on in this course, but for now we will learn the basics, and for the next steps we'll do the script programming, just the script programming, that you get a feeling of what you should do, how programming really works. So what do we need for a script? We need something which helps us to control our application, to control our application flow. So therefore we will have a look into our application flow control. What does it mean? We don't want to do each command every time, so we want to do it selectively, so that we can say if a file has 10 elements, then do this. If it has 20 elements, then do that. Or if the user wants me to plot the whatever plot, then do this. And if it does not want to plot anything, then don't plot. So therefore the control with menus, so that we do a selective sequence of code or things like that, is a very essential part, and therefore we have to control this. Also repeating things, and therefore we have to continue with the first statements, and the first one is the conditional statement. So I will always explain it first with a slide, and then I will show you directly the behavior of this in the script. As I said, we now use scripts again. You can also do this in functions. It doesn't matter. But with scripts, it's easy to test it, because, do you remember, we can just click the run button and then the whole script is operated. We don't have to think about handover arguments and things like that. So for learning at the moment, it's easier to deal with scripts. For the later on sophisticated programming, you should keep in mind there the concepts of functions. So what is a conditional statement? Conditional statement already said that you need a condition. So if something is true, so if a is bigger or greater than 10, then do this. You see again, remember, it's something like in the functions. You have a block of commands. this block of commands are just operated if this expression is true. Then if this is not true, go into the next else if. So else, if this expression is true, do this block of commands. And if else if next, else if next. So you can have a selective way of code which is operated according to these different expressions or conditions. If nothing of this is true, then do this here. So do the else part. So in this case, you have a conditional statement which starts with if and ends with and you can have an optional number of these sequences. So there is a possibility that you just have if and an and. You can have an if and just an else. You can have an if and else if, or an if and several else ifs, and you can have if, else ifs, and else. So you have different combinations of that. The conditional statement must look like this. You can have comparisons, so the comparator operators which return true or false. False is always 0. True is not 0, so it's greater than 0, for example. So you can ask for lower than or equal, greater than or equal. So these operators are very similar to what you know from other languages. The only thing not equal is different in different languages. In this case, you have this tilde sign and the equal sign in combination, which tells you not equal. So what you can have here now is different comparators which define your expression. And if you have more than one expression which must be true, or which either one or the other must be true, or something like that, then you can combine these different expressions in one condition by these logic operators. These logic operators are these double and, double or not symbols, and therefore you see one example in the lower part of this page. If parenthesis open, then again parenthesis open, attendance greater or equal to 90%, and grade average is greater or equal to 60, then it's passed. So you combine these two expressions, these conditional expressions, to one condition by using these logic operators. So let's directly have a look at this in our program. Do you remember? We created this script, and now we want to change this script. In script, we always start with clear all, close all, and CNC. And now we want to change this script. So in my case, I want to change it in this way, that I have a condition for the input, and then that I have a change in the matrix. So we create the matrix, then we want to print the matrix, so that we now create something like a real script. So disp the matrix currently looks like this. Disp matrix, so that we print it now, and then we can ask for activities. So we create a menu, so we tell the user that now a menu follows, and then we display the possibilities of the menu. For example, print matrix, and then we tell the user that he should enter the 1. And then we request something from the user. So we remember we have this input, and we say selection. And then we requested the input. And now we can use our knowledge from the if statement. So if menu item is equal to 1, then we display the matrix again. End. So let's do this. You see the matrix is printed. Now menu is printed. Print matrix, enter 1. So we enter now 1. And now the matrix is printed again. So if we do the same stuff again, and if we enter something different, then nothing happens. So therefore we can change this and we can enter an else condition. So if something different to this is entered, so if for example a number non-equal to 1 is entered, then we display error. So later on you will also see additional output scenarios, so that you have error with red color or a warning, things like that. Until now we just know the disp, so we use this. And let's start this. So if we now enter something different to 1, then you will see that error appears. So let's make it a little bit more specific. Error, you entered the wrong selection. Okay, so we can now extend this menu. So for example, let's say we have an additional menu output. Delete first row, enter 2. And then we can have this else if condition. Else if menu item equal to. And then we can delete the first row. How do we delete the first row? Matrix first row whole columns equal delete. So let's see what happens. We now have this matrix. Then we enter 2, and we deleted the first row. And then we can print the matrix so that we see, oh, it really happened. So we have now an interactive mechanism without changing our program and without typing all the time the comments into the comment window, to manipulate and to influence the flow through a sequence of commands. Before we continue with another conditional statement set, we have to have a look into the behavior of these comparisons. So what I did is a comparison between a constant and a variable, so a single scalar. But what happens if you compare matrices? So matrix comparisons are always comparisons element by element. So this means the dimensions must fit, and it always compares the element at index 1, 1 with the element of index 1, 1 of the second matrix, and so on. So let's have a look onto these matrices. We have the matrix A and the matrix B. So matrix A is this, matrix B is this. And if we now compare A is lower than B, what will happen? So it will compare. A is lower than B. Is 1 lower than 1? No. So therefore, it's not true. If you compare this, A is lower than B plus 1. So you see that you can directly do calculations if you use this parenthesis here. So if you calculate 1 plus 1 is 2, 2, 4, 5. And then if you compare it, 1 is lower than 2, 0 is lower than 2, 2 is lower than 4, and 3 is lower than 5. Then you see it's true, because you will get an element by element truth state. This here now deals with these operators of logic. So it's not only possible that you combine real truth statements, so real logic expressions. It's also possible to take normal numbers like logic numbers. So do you remember? False is 0 and true is always something which is not 0. So therefore, you can directly have a look into these two matrices, and you can do this A and B. So A and B means that both must be true. I can have a short interrupt to show you what these conditional statements mean. Do you remember? We had this and, the or, and the not. So and I want to show you now what this means in case of a truth table. So if we create a so-called truth table, then we'll have the left side and the right side of this and, for example, so that A and B, the truth values of this, are combined with and. And you can have now the different possibilities that both are false, one is true and the other false, or both are true. So and the and tells us now that if both are false, the and is also false. If one or the other is false, then the and combination is also false. And if both are true, only then the output is true. So compared with an or, you have the same situation. So you have the A and B, so which means these are the two terms which are combined with this or statement. So this is this and this is this. And if we have the situation both are false, then the or is also false. But if one of the inputs is true, then the or is also true, even or also especially if both are true. So in this case, the and is only true if both are true. The or is already true, so the combination of the or is true if both are true. And if we have the not, so the not is this, then you just have one input, and the input can be true, or let's say false or true, so that we have the same order. If it is false, then the output is true, and if the input is true, then the output is false. So these are the three different combinations of and, or, and not. And this must be used in this case of combinations, so that you can have different statements where not only one condition is checked. Therefore, let's continue with the same stuff. If you now compare this, the AND, each of the elements must be AND combined. This means true is not 0 and false is 0. So in this case, we have here true, here false, here true, and here true. So if we combine now, true and true is true. Remember the table? False and true is false. So we don't have to continue because we already know that A and B, so this here, A and B is false. So it's again an element by element evaluation where the numbers here are now treated like conditional values, so truth values, Boolean values, which have just true or false, and they come to a result in the sense of a conditional evaluation or a logic evaluation. Let's do the last one. B lower than 5. B lower than 5 should be clear. So we have one scalar, and this scalar is evaluated against all of the elements of B. So 1 is lower than 5, and 3 is lower than 5, and 4 is lower than 5. So all elements are lower than 5. So this will be true. Therefore, you see different conditional evaluations here. And you should always keep this in mind, that matrices are always operated here in element by element style. Let's come to another conditional statement, which is the switch case statement. So I directly explain this maybe with our menu so that you see what is meant by this. So let's jump to Matlab. You remember we had this setup. So we have a large sequence of if-else conditions, and each of these if-else conditions or if conditions just check a scalar against input variable. This can be simplified with this switch case statement, because a switch case just compares with equal, and we can compare a special value equal to another scalar, for example. So let's do it like this. Switch. We compare menu item, and then we compare it with the first case, that menu item is 1. If we have this, and then we display, and then if case is 2, then we do this, and otherwise we do this. So you see the if-else construct is now very simplified. So we just compare always menu item equal 1, menu item equal 2 otherwise, and we don't have to write the whole stuff of the condition. So let's test what happens. So if we run this, we can do the selection and we print it. So it's exactly the same what we had, just with a simplified version. So where we have the comparison always between this and this. In Matlab, you can also compare here strings, things like that. So let's jump to the slide. So for example, in this case, we have a string here, and we can use lower, which converts the complete text in lowercase, and then we can compare bilinear to this bilinear writing, so that here is uppercase letter, and then you can also compare strings here, but it's always an equal comparison, so that you always compare equal to equal. Okay, With this, we have now conditional statements. Conditional statements help to decide or to have paths which are split in your program. So, for example, you have a situation where your code does a piece of code only if a special condition happens, and does another piece of code if another condition happens. This can be shown in a graph like this. So if I switch to my external camera, a switch case or an if statement is something like this, that you have a question. So this is the condition. The question is this condition true or false? And then if it is true, go to this way. If it is false, go to this way. So this block is operated if it is true. This block is operated if it is false. So it's a splitting of your workflow into two different branches. What we now also need is we want to repeat things so that we do things more than once. And this can be done with loops. There are two different types of loops. One is I would say counting loop, and another is a conditional loop, where the counting loop does exactly the commands in the loop block a dedicated number of times, which you define by your counting index evaluator, something like that. And in the conditional loop, you do the commands in the block as long as a condition is true. Let's start with the for loop. The for loop looks like this. So you have a reserved word for, then you have a variable equal a matrix in a vector in this case, and then these block commands, so everything what is inside this block is operated according to the counting here in this vector. It's very theoretical, so let's directly jump to the Matlab sample. So we want to extend our menu. So let's say we want to print now the matrix with our own method. So let's extend this. Print matrix own style. Let's say this is 3. So you remember, switch case statement. We have case 3. And case 3 is now our printing. And here we want to use the for loop. So that you see the for loop, how it works. We want to print this matrix. Let's start with the first row of the matrix. So for index E equal 1, 2, and now remember size of matrix. And we want to select the first row. So we need the number of columns, and this is the second dimension, so that we have now an index counter from 1 to the size of matrix second dimension, which is the number of columns. And we now want to display everything from the matrix. So matrix, we are in the first row, and we want to print the first row completely. So in this case, we print the matrix first row, and we use at a second index this counter. So in this case, the index E starts from 1. The next one is 1 plus 1, 2, 3, 4, 5, and so on, until we reach the second dimension, which is the number of columns of our matrix, and then it will stop. So let's see what happens. Let's start. To remember, we have to push 3, and then it will go through the whole columns of the first row. Now we want to print the whole matrix. So let's do a nested call. So we push a second for loop into the first one with index j equal 1 to size of matrix. So, but now we have to change this because we want to first count the rows, and in the second step for each row we want to count the columns, and then we can use here index I and here index j. So what does it do now? This counts from 1 to size of matrix dimension 1, which is the number of rows. So it counts from 1 to, in this case, 3. Each counting step we start this block, and in each counting step now a new counter starts from 1 to size of the second dimension of matrix, which is the number of columns. So in this case we have 4 columns, so it starts from 1 and ends with 4, and each counting step we do this block. So we start with 1 1, then 1 2, because we do not leave this for loop, so until we do not reach the maximum number here, we continue. So we have still 1 in the first index and 2 in the second index now, 3 in the second index, still 1 in the first index, 4 in the second index, and 4 is the maximum here, so the end of the matrix dimension, and then it continues, goes out of this for loop and continues with the next counter here in the first for loop. So we go from 1 to 2, so the first index will be 2, then 2 1 again, it starts with 1 again, 2 1 2 2 2 3 2 4, then 3 1 3 2 3 3 3 4, and so on. So we have 2 nested for loops now, and if we run this and if we push 3 here, now we will see that it runs through all of the rows and all of the columns. So please play a little bit with this so that you understand this concept of the for loop. Let's do it manually here again, that you see what the counter does. So if we write for index equal 1 to 10, and if we just print the index, then we will see that it counts from 1 to 10. Okay? So if we now print a second for loop, so that we do the first for loop as we have it, and then we have a second for loop, index 2 equal 1 to 10, then we can do the following: display index and display index 2. And if we start this, you will see this mixture of numbers. And this is the output of the index 1 and index 2. So we have 1 1, 1 2, 1 3, 1 4, 1 5. So the first index is always 1 until we reach 1 10, and then the first index, so the second loop stops and the first index counts to the next. So we have 2 1, 2 2, 2 3, 2 4, 2 5 until 2 10, and then the first index counts to 3, and then we have 3 1 3 2, and so on. You see the principle of the for loop. So it's a counting loop, and you can use this for all counting mechanisms where you already know how many elements will exist, or where you can derive it from the matrix with size, for example. There is another type of loop which is the while loop. The while loop is a conditional loop, which is similar to if-else. But don't mix these things up. If-else is just one separation between the workflow. So it means there's one conditional check, and then the block of the if or the else part is done. Here, the while loop, there is no else part. There is a real repeating version. So while, in this case, and the expression means as long as this expression is true, these statements will be operated. So students often mix this because they think there is an expression, so both are the same. No, the if is really a conditional statement. The while is really a loop. As long as this expression is true, operate these things. So let's have a look. What is the difference to our for loop? Let us do a crazy thing. So let us change the for loop so that it is replaced by a while loop. So you directly see the differences between for and while. So we extend our nice menu. Do you remember? So print matrix unstyle with while. It's our part 4. We have a new case statement. And in this case statement, we do now exactly do the same like with the while, with the for loop, now with a while loop, so that you see the difference. So now we need conditions. So while, and here we need this condition. So what is the condition? In this case, the condition is the size. So if index I is lower or equal size of matrix 1. So this is our first condition. As long as it is lower or equal size 1, we can operate this. As it is now not a vector which is filled during the startup of the for loop, we have to create our own starting index. So we have now a scalar. This index I is now a scalar, and it starts with the first index. So it starts with the first index. It compares the first index, but there is no counting at the moment. So it just compares, and as long as this is true, we will run this. So in our case, we'll operate it now endlessly. So let's test this, and so that you directly see the Control C use. So we'll print now matrix, let's say the first line again. Oh, the first index is the line again, and we print always the first column. So if we do this, and if we go to the first, then it will never end anymore. And then we have to push Control C to interrupt our program. What happens? Again, we created a scalar with the starting value 1, and the starting value is now compared to the size of matrix, which is 4 or 3. We have 3 lines here, yeah. So it's 3 because we are in the first index or the first dimension. So, and it always compares 1 with 3, and it will never change. So therefore, what we have now to change to get the same result than with the first for loop, we have now do this counting ourselves. So after each comparison and activity, we add 1 to the index, and then we can use this. So let's test it again. So now we have 159. Let's go back to this 159. Okay. So let's replace the second for loop here again. So in our case, we have a new while loop. This while loop is index j is lower or equal size of matrix second dimension. we do the printing. Now we can use this. So we have index y, index j. What we already remember is this. So that we have now do the counting for this index j ourselves. And each time we start newly with the second loop, we have to define the starting index of this j. So index j is equal 1 again. So that we have the same here. We start with 1 and end with the last index, and we do the displaying. So we define a start, we do the comparison, then we do this block, and at the end of the activity we do the counting. So, and if we run this now, it should end up with the same output like if we would use the 3. Okay? So now we replaced the for loop with a while loop, and therefore we directly see the differences. Let's make the complete screen. So if you compare this for loop, it's a counting loop, so you have directly the start from 1 to end of the matrix dimension, and you create a vector which is step by step walk through the indexes. Here you have to do this counting for yourself. You just have a comparison. This comparison can be anything as long as this condition is true, and you can also use the and, or, and things like that. As long as this is true, it will be operated. And then you have to do your counting for yourself. So in this case, you define the first index, then you do the comparison, and then you do this addition so that you have this counting. And then the second for loop, so this block is replaced by this, so that you have the same stuff again. And this is the big difference. So the first one is more or less a counter. The second one is more or less a conditional statement with loop, so that you have, as long as this conditional statement is true, the next block is operated. With all for loops, you have a scenario like this. You split your code into a part which is repeated. So these instructions here are repeated, and here you have, for example, in the while loop, a condition, and if this is true, or as long as this is true, this is repeated. So you have a setup of commands, and inside of these commands you have a section of commands which is repeated several times as long as this condition is true, or as long as the counter counts. And with this you can now play a little bit with specifics of computers. So for example, with numerics. And you should always keep this also in mind, that a computer is numerically not really mathematical equipment, because if you have iterative steps and a limited world, you have not the possibility to represent each number, or every number you can represent in math. And therefore you have limits. You have the maximum and the minimum, as explained in the first lesson, and you have another minimum, which is the step between two floating point numbers. So the maximum or the minimum step between two floating point numbers, and this is shown here with this epsilon. So if you run this, you will see a special behavior. Let's walk through this while loop. So remember, we set the initial value, then we compare and run this block of commands as long as we have a true here in this statement, and if it is not true anymore, it stops. So what do you think do we get here? So let's do it. So we start with 1. Then we do 1 plus 1 in this case. 1 plus 1 is 2, and it's bigger than 1. So it's true. So this is true. Epsilon equal epsilon half. So epsilon is 1. Epsilon will be half, so 0.5. So the loop continues with a while. So 1 plus 0.5 is 1.5. Bigger than 1. So it's true. 0.5 is now divided by 2, so 0.25. The for loop is operated again. 1 plus 0.25 is bigger than 1. So we operate again. 0.25 divided by 2 is 0.125. So 1 plus 0.125 is bigger than 1. So we operate. So it will always divide. And in math, this will never end. But let's have a look what happens if you do this with your Matlab. Of course, I already prepared a small script doing this. And here you see the script, which you find also in the slides. And if you compare this, we have exactly this division here and the comparison. So let's do a run of this program, and you will see it stops. It will print a special number. But in math, we would expect that it will never end, so that we would have to push the Ctrl+C button. What happens here is that numerically we will reach a situation that the number is so small that it is not representable anymore with the binary number, so that we have a number of bytes and bits, and that these bytes and bits are not enough anymore to represent this, so that the smallest piece is 0 now, so that the smallest fraction is 0. And if we reach 0, then we will have here 1 plus 0, which is not greater than 1 anymore, and then it will stop. And another nice thing, what you see here, is that we already reached this situation of 0, but if we use this result here again and multiply it by 2, then we'll come back to a usable number. How can this be? It is because we have more precision than what we see. So we have additional places after the floating point dot in the positions far behind the floating point dot, which is in use but is not printed. So that we have a little bit of space for rounding errors or to avoid rounding errors. But nevertheless, we will reach a situation where these rounding errors come to representation which cannot be pushed into the current number of bytes. But it works that we use this result here and multiply it by 2, so that the relevant section comes again into the visible section, and then we can print it. And what we get here is nothing more than what we know from the constant or the constant function eps, which is the epsilon. And if you remember the first lesson, this is this smallest number or the smallest step which we can have between two floating point numbers. Let's do another thing with a while loop. So if we go back to the program which we already had, if we call this, then we can do the menu only once, and then it will stop. If we want to continue, for example, so that I always are re-asked for a new input, then we will have to write a loop, and we'll have to write a loop which is not countable. So we don't know when the user will enter the stop command or the stop item. and therefore we'll have to write a while loop. Let's do this. In this case, we always want to repeat these menu. Therefore, we have to start with a while loop here. So while, and then we use the input here. So while menu item is not 0. Do all of this stuff here. So therefore we will do this indenting because now it's part of this new block. So take this time and do it, because otherwise it will be not readable anymore. So I do it here to that you see it's a lot of work, of course, but it will keep the situation so that it is readable. And you see always the positions, the columns here define to which block it belongs. So in this case, I always use 4 white spaces as indent. So otherwise, and then we end the while loop. So remember, what do we need for a while loop? We'll need the initial situation. So in our case, menu, for example, is 10. So let's start with a menu item which does not appear, so, or let's say 100. So that it is not 0, so that the loop starts and then it continues. And then we can make an additional menu item. Stop processing, enter 0. And we have one additional case statement for 0, which is now a method to interrupt the repeating. You find it on the slides at several positions in the for and then the while loop. Now I want to come back to this. I didn't mention it until now. And it's the break statement. Break means stop the while loop at the position where you are at the moment. So if we have this, we can now let it run, and you will get always a menu. So I can always do this. And if I push the 0, then it will stop. So again, what I did is I wrote a while loop until this while loop checks the condition. And the condition is not 0. So if everything what I enter is not 0, I will always get a new output of this menu. I can do a new input of a selection. And if I have the 0, then I do a break. Until I don't do this, I will have a repeating of this while loop and of this requesting of menu items. So with this, you should have now a nice overview of loops, which gives you a lot of possibilities to interact with your user and with your code, so that some things are repeated several times, some things are repeated as long as a special condition exists, and other things are just done if a special condition tells that it should be done now. So like here with a switch case or if-else construction, you saw also the difference or the similarity between if and switch case, or between for and while loops. So please repeat this several times so that you understand the principles, that you understand also the differences between while and for loops. So a for loop is just a counting loop, and a while loop is a conditional loop, so that you need a precondition or a pre-state, so an initial state, which defines that the condition is true, and a while loop always runs as long as this condition is true. So let's jump back to our slides, and here we still have one gap which deals with input and output. For this lesson I will focus on input and output with the operator or with a user, and with a simple way to store and save your special matrices and to load it back into your memory. You will also see the extended version of file manipulation. I just mentioned it here, but you will see it later on in the project, because as I said, sophisticated programmers need a little bit more of that stuff, and therefore you have to learn a little bit more. But let's start with the simple input and output. It's just a repeating of what you already know. So we have input with a prompt, we get the result. You already know this. We also have disp, which prints the text or the content of a matrix. In this case, if you want to mix up text and numbers, you have to go another way. You have to do the following. You have to use num2string. So if you remember, I said that there is a difference between numbers, so real numbers, and text. In principle, both are vectors, but text is based on the ASCII table, so it's just the conversion between a position in a table, a lookup table, and the character sign. And normal numbers are real numerical system representations in the binary format. So let's clean everything. So if you have now a number like item equal 10, and if you have a text like my item is, then you have two different types, and you cannot mix this. If you, for example, would think, okay, these are just vectors, so I can do the same like this. I do item and then I combine it with text. Then you will see that it is not mixed, because this item is now used like a lookup position in the ASCII table, and it is not the text which you want to print. So you don't see this number 10. Therefore, if you want to do this and do it directly in the right order, you can make the following. You can make num2string, and then you can put item inside of these arguments, so that this function converts a number to a string. And if you do this, then this item, this value, this real representation in a binary system is converted to a text which consists of two characters, a 1 and a 0, or the sign for a 1 and a 0, and now it can be printed. So this is what I wanted to add here at this position, and then we can directly go to the additional output scenarios. For example, you have this display, but for example, if you want to tell your user that there are situations which might lead to problems, then you can write a warning statement. It's the same like display, so you can directly use the same stuff what you can use in display, but if you do a warning, it is then colorized with orange or yellow. And another thing is, you can do the same as error output. Error outputs do a sound and they colorize it with red. And there is one special thing what you should also know. If you call this within your program, then it will interrupt the program. So the program will stop at this position. You don't have to exit your program. It will automatically stop here. So therefore, errors are critical situations. So for example, a file does not exist and the next steps are not possible. Warnings are situations where a problem appeared, but it was solvable, or it has no influence to the next steps. And display is just for information output, so that you can show what is the content of this stuff. So this is how you can inform your user. If you have output of numbers, you can also tell the Matlab program which format should be used. So you can have the standard format with 4 places after the dot, the floating point dot, or you can have different other formats. So here are some format outputs which you can define. So if you make format short, for example, then you have a fixed point with 4 decimal places. So this is the standard, the default. If you have format long, then you will see all 14 decimal places. If you have the E, the short E, then it will have this scientific notation with 10 to the power of something, and so on. If you change the format, then the format will be kept until you enter format again without any additional handover argument, so that the format goes to the default behavior, which is format short. With this, you can have some effects on the output, so that you can decide which precision should be presented. Okay. And this is what I already showed you, the error and the warning statements. Let's go to the next thing, which is not a direct communication to the user, which is reading from a file or saving to a file. So I will focus onto the first section here. The rest is for, let's say, completeness. I will explain it quite short, because we will come back to this later on in the different parts of our project. But the first thing you should directly know. If we go to Matlab, and if you have a matrix available, like here, then you can store this matrix in an easy way with a save function. So if you store this, you usually do the following. You save, and then you give a file name like my matrix.txt or .mat, and then you define the variable which you want to store. So in this case, matrix. Take care that now you have to use this single quote to identify the matrix, because save uses a sequence of commands or of handover arguments which identify also some parameters for the saving, and the order of this is not defined. So you can have a different order of these things, and you can also store more than one single matrix in one file, and therefore you can have different sets of these arguments, but you always have to identify it with these single quotes. So let's do it first in this way. So if I save this, I will get a matrix file where my matrix is stored now. If you open this file with an editor, you will see that it looks like this. You have a readable header. The readable header tells you that it is a Matlab file, and the rest is binary. So it's not readable, human readable. So all of the information is stored as a binary information, and it also contains the name of the matrix. So if you want to load it back, then you can create things again as they were, with just a load command. So let's clear all and clean up. So remember the file was mymatrix.mat. So if we call load and do mymatrix.mat without anything, then it will load everything again with the same name as it was. Let's do it again. Let's create, for example, also an iterator. And let's set it to 10. And let's do another matrix, matrix2 equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we have this, and now you can save these different matrices in that way. And matrix 2. So that all of these matrices are stored now. If you open it, it would look again like a binary file. And if you clear everything, and if you load it back, then you will have everything as it was before. So it really stores the name of the matrix, it stores the content of the matrix, it stores everything. With this, you have now a simple possibility to make data which are required later on persistent on your hard drive. So the files will be in the same folder like your Matlab programs. You can also define here in the storing part here here at this position, so you can make here the definition also of a complete path, so that you identify a complete path with a file name, so that you can have different locations of these files, all of these things. But it is not human readable. If you want it human readable, you can save it as text file. And there is a small difference. You have to set additional attributes, which you can do during this save. So let's do it with this new method. So we have matrix, matrix2, and I want to save it now with an ASCII format. And therefore, I define it like this. Save, file name, .txt. We want to save matrix, and we want to save it as ASCII. So, and if we do this, and if we open the file again, you will see that now the file is text-based. So the numbers are ASCII signs, and they are human readable, and you can process this data also with another program, for example with Excel or something like that. So it's a tab separated or a white space separated list of numbers with always the same precision in this scientific representation. So if you want the double representation, for example, you can do an additional argument. You can make here minus double, and maybe you directly see what is the difference now. Let's first open the file, and it looks like this now. So you see it's now a large precision, but you directly see here in this call the difference. So arguments or parameters which you want to set always start with the minus, and it doesn't matter if you write ASCII first or double first. So the order is optional. The only thing is that it always has to start with the file name, and then you can have a list of matrix names, and you can have a list of arguments. So a big difference between the binary version or the Matlab version is that here you can just store one matrix, because here you have again the situation that the dimension must fit. So if you have two matrices and the dimensions do not fit, there is no chance to divide these two matrices automatically by Matlab. And therefore, you have just one matrix where you have a clear dimension setup. So if you want to store it with Matlab format, you can use mat here. And then it's binary again. So if you read the file, then you have a standard behavior as I shown with load. But if I store it in that way, I have to load it again as ASCII text. So therefore, I have to do load of my file name. And I have to tell Matlab that if I don't do it, let's do it like this, then Matlab reads it and creates a new matrix which has the same name like the file name. Okay, so if I load this and I do the definition, then I have to arrange it to a matrix name, or sorry, to matrix of course, so that it is again in the right name of the matrix. So it does not contain, the file does not contain the name of the matrix like with a binary format. And if you want to explicitly tell Matlab that it should read it as ASCII, then you have to tell Matlab that it is ASCII. Okay, so you see now the differences. If you store it with a Matlab format, you have also the information containing the matrix formats and all of this stuff, and you have the dimensions. You can store more than one matrix there. You can store the complete workspace there, and you can reload it so that you have a setup as known before. And if you store it as text file, you don't have the name of the matrix available, and you have to define it individually so that each matrix must be in a separate file. If we go back to these methods, on top of this here you find all of these possibilities, and here there's another way to get information from a file, which is the sophisticated way. With this you can just store or load files which are oriented like Matlab matrices. So files which follow the Matlab binary format, or which follow a style like a table in text format. If you have different other formats like XML, NetCDF, Excel, whatever, then you have a format description, and this format description cannot be directly read with Matlab if Matlab does not support it, for example. So there are additional functions which support already the reading of Excel files, things like that. So Matlab is a huge package. But if there are formats which you cannot directly read, then you have to create your own reading mechanisms. And this can be found here. If I go to the screen, then you see a method which goes to the so-called low-level functions. So the F functions. All functions for file read, for a simple file read, start with F. And they follow always the same principle. You open the file and you will get a file ID, a file handle, a file descriptor. It's named in different ways. It's in principle the pointer to the file, or identifier of the pointer to the currently opened file. You open the file with a file name and with a definition how you want to open it, reading or writing. So in this case we want to read from this file, and if you open it and if you finish this, then you will find also F close. So all file functions start with F in the name, and you have to open it and you have to close it. And for each following functions you always need this file identifier to identify the file from where you want to read, or the file to where you want to write. So if you open it, you will get a file descriptor, it will be -1 if the file could not be opened. So usually you will request, or you will check with the if statement if the file opened successfully, and then you can do a reading here. For example, in this case, there is a read of a character with 5 different elements. So it reads 5 different character elements, and then it closes the file again. And then to write into a file, you can use the printf function. There are a lot of other functions for reading, for example, get strings and things like that. There are also other functions to print to the file, but one is the sprintf, where you use a special format, and then you read this into a variable which has this name. So into a matrix which has this name. So it's a reading of this, which is the character. It's a sequence of characters into this variable, and another sequence of characters, and another sequence of characters into these different variables. So there are 2 possibilities of a little bit more extended reading and writing. It's just for completeness here at this point. Nevertheless, we will come to this again later on, because usual programmers will deal with this stuff. They because not all functions, not all formats are predefined in Matlab. So if you do your own files, and if you have to read your own scientific data, you will need this stuff much more than what you think at the moment. But for now, load and save should be enough, so that you can start with training a little bit of these functionalities. So we are now at a position that we can deal with different programs, or with different ideas to create programs. So we are able to write single commands. These single commands can be packed into a script file. In this script file, we have the chance to select if a special condition appears, then we do that. If not, and we do that. We can repeat things. All of these things are possible. If you write programs, then you should directly keep in mind that some things are faster or more efficient than others. And therefore, I want to give you a few small pieces of information which you directly can integrate into your programs to speed up your code. So what is the main driver of speeding up your code? So what should you take care on? And therefore, I can make a short interrupt to the so-called John von Neumann architecture, because each time if you leave the processing unit in this John von Neumann architecture to the external world, to the memory, or to the external monitor or keyboard, it will cost time. And therefore, it's always a nice idea which you can keep in mind, that if you have this John von Neumann architecture and you pass one of these arrows there, then you will have some cost-intensive work. So therefore, let's go to the John von Neumann architecture. The John von Neumann architecture is a principle which makes some blocks according to the things which are done there. So in our case, we have an input, we have an output. So we have the interaction to the user, which comes from the input and goes to the output. And we have a processing unit. So a processing unit does the arithmetic logic calculations. So the logic things we already know from the conditions, and the arithmetic calculations. This is controlled by a control unit, and both are combined to a so-called CPU, central processing unit. It uses a memory, and the principle of programming is now that you send via the input the commands and the data to the memory. So if you remember, we define matrices and we define commands, and we directly process the matrices with our commands. So everything what we do is already located in the memory. So we send in data and programs to the memory, and then data and programs are processed through this CPU. You don't have to know it in detail. What happens here now if you run a program or if Matlab starts. But what you should keep in mind is that the processing happens and then it produces new data, for example, in the workspace, so in the memory, or it produces output to the screen, to the monitor, to the command window. So, and this idea here of John von Neumann architecture can be found again to simply identify some time-consuming activities. So everything what runs inside of this CPU is quite fast. If you have to get things from the memory, it will cost time. So for example, if you store something in the memory and you reassign it so that an extended version of the existing matrix must be realigned to the memory, then it costs time because you leave the normal workflow in this way that you have to create new memory, you have to copy the data to the memory, and you have to delete the old memory. So a lot of steps which will go over these arrows here. Also, if you have to enter something, if you read from a file, so you have to go to an external device, costs time. And if you write to a file, or if you send something to the monitor, then it costs time because here you leave external the border to the external world. So in this case, input and output is very cost intensive. So remember, using the semicolon or not will speed up your program tremendously. And also, if you do rearrangement in the memory all the time, then it will cost a lot of processing time. Let's make a short overview what we have in the John von Neumann architecture. We have the input and output, which is used to commit data and programs to the memory and return them to the user. We have the main memory, which stores data and programs. We can keep it in the workspace, so like that. It offers it to the CPU. The CPU processes this. It's split into control unit and arithmetic logic unit. So it stores the current instruction in registers, counts them, and decodes them. So it processes the data in the way that each command is processed step by step, and it does the commanding of the arithmetic logic unit so that the calculations and also the comparisons are done. So this you should keep in mind. And with this idea, we can come back to the idea of efficiency checks. So Matlab offers a nice tool or nice functions to measure the current runtime. It's not a real representation of the efficiency because it also measures time which other programs acquire during the run of your program. But it's a first hint of how fast your program works. So you can use this tick-tock mechanism. So what you do is you set in front of the thing you want to measure, so in front of the commands you want to measure, you set a starting time event. So it's tick, which starts the stopwatch, and tock stops the stopwatch, and then it will print out here the number of seconds these commands had required. And with this you can measure the different sections of your code to get a feeling of how fast the sections are. So let's do it for different versions. So here we compare two different methods of dealing with matrices. In the first one, we create the matrix at the beginning and then we just change the positions, the values of the matrix. In the second one, we really create each part of the matrix step by step. So here we rearrange the memory, we realign the memory. And then if you compare this, you will see that the first one is 3 times faster than this. Why? Here we create memory, we set the value. Then we create a new larger matrix, we copy the old into the new, and we delete the old one. So this happens inside of the computer. So therefore there are a lot of more actions here than here. And this knowledge can be used if you have large matrices, really large matrices with millions of lines of data. And then if you do this, it is really tremendous if you have 1/3 more of speed than this here. Okay. Another thing is if you do the use of existing Matlab functions. Existing Matlab functions are internally programmed and they are quite fast. Also, the dot operators are quite fast because they deal with Matlab specific things, and therefore if you program a for loop and doing the sign of each single element compared to doing one step in the sinus function which is offered by Matlab, so that you do the whole matrix or the whole vector in one step completely, you will see that this is much faster. In this case, you directly see it. Your for loop is slower than the internal program of Matlab. So you should always trust in what Matlab offers you. Don't do your own programming. Try to convert for loops into dot operators, so which means in element by element operators. It's much faster than a for loop. So therefore you can speed up your code by just keeping this in mind. And another thing is, of course, if you leave your processing unit to an external device, so if you do this semicolon output or not, so if you output data, then you will see it's much slower than not outputting data. So therefore this echo off is quite useful, and the semicolon at the end of each command in a program is also quite important. What I should also tell you is that you have always a mixture between speed and size of memory. So if you have large matrices and you want to speed it up, then you have a large set of data and the program is fast. If you want to reduce the wasted space, so for example, if you have a matrix which has a lot of zeros, then you can store it as a so-called sparse matrix, so that the space on your memory is reduced, but for using it in your program, the program will need more time because it must restore it to a normal matrix. It must do a lot of operations more. Therefore, you have always a mixture of speed and memory. So you must find the optimum between the usage of memory and the usage of speed. Finally, I want to show you that you can also do some animations with your Matlab, because you can change everything what you see in your Windows, for example. So every button, everything what you see there, you can do also in a Matlab program. So therefore you can change the view angle, for example, for three-dimensional plots, things like that. And I want to show you this with a small example which shows you some glasses in a 3D plot. The 3D plot looks like this. So it means we created a spline function of all of these positions of these glasses. And what I want to show you in the program is that I can rotate this. So let's go to Matlab. And let's start this program of sunglasses. So if we let it run, it will create a window of the sunglasses, and it will change the viewing angle step by step so that we see the three-dimensional plot from different positions. So you see it, you can even create small animations with these while loops, because behind this is nothing more than a for or a while loop which changes the view angle. And this while loop looks like this, or this for loop in this case looks like this, that you use the view function which defines the view angle, and you do it in this case 36 times, so that you have each 10 degrees one viewpoint, and therefore you have a 360-degree view onto your three-dimensional plot. And isn't this nice? With this, you have now a chance to create your own data set. You can manipulate data. You can run through this data as you want. You can plot the things. You can plot it in 3D, and you can even create a small film with your data. So isn't it great? You learn now everything, or almost everything, for a beginner, for the basics of Matlab. So try to train this. Try to understand the principles of while and for loops, the principles of if conditions and maybe switch conditions. Learn how to store and load data with the simple functions load and save. And try to learn this, because everything what you learned until now can be used to solve the project. So you need not much more. Of course, you can do it in a more sophisticated way. You can do it in a real, let's say, programmers-like style, with functions and with different methods to read data, so that you improve your way of programming. But everything what you learned until now is already usable to do your own stuff. And therefore, we will start next time with a project. See you, and stay safe.